All right, so the question came up, how do you relate between orbital radius, planetary radius, and altitude? So the way to do it is draw yourself a little sketch that shows the central body, as I call it. And that is whatever object that we're choosing to talk about that is large enough that we can consider it to be a space object. So it could be the moon, it could be the Earth, it could be the sun, it could be a galaxy, it can be any object you want to deal with. It has a diameter, of course, that is equal to twice its radius. And for its radius, I'm going to be using capital R. So from the center of the central body, whatever it is, to its surface, that distance is the radius of that object. For the Earth, it's like 6,000, almost 400 kilometers in radius. Whatever the central body is, we're going to be doing calculations of objects orbiting that central body. And we can describe their location using two different variables. The first one, the one that we really want to use all the time, is called the orbit radius or orbital radius. And I use lowercase letter r to represent that variable. It is very common, particularly when talking about Earth orbiting satellites, for us to refer to that satellite in terms of its altitude above the surface of the Earth. This altitude I represent with lowercase letter h. Now, there's a simple geometric relationship between the radius of the Earth, the orbit radius of an object orbiting the Earth, and the altitude above the surface of the Earth. And that relationship mathematically is the orbit radius, lowercase r, is equal to the radius of the central body, capital R, plus the altitude h above the surface of that central body. For example, if I told you I have a body that has a radius of 5,600 kilometers, and I want to go into orbit that is 280 kilometers above the surface of that body, then the orbit radius, which is what we use in our calculations, would be the sum of these two values. So you add them together. I get 5,880 kilometers as my orbit radius in this example. Another example. What if I told you that the diameter of some planet is 14,500 kilometers and the orbit radius is 12,300 kilometers. Okay, so what's not known? What's not known is the altitude above the surface of this planet. This is the planetary scale dimension here. Well, to get that altitude, we look at this equation that says orbit radius is equal to planetary radius plus altitude. And we rearrange this equation to solve for altitude by subtracting the planetary radius from both sides. So we have altitude is equal to orbit radius, lowercase r, minus planetary radius, capital R. The diameter is 2 times the radius. So if the diameter is 14,500 kilometers, then the radius, capital R, of this planetary body is going to be half of that. Half of 14,500 is 7,250 kilometers. Now, to solve for the altitude, h, I'm going to do this planetary radius, 7,250 kilometers, and subtract from it I'm sorry. I am doing this slightly wrong, right? We're trying to solve for the altitude, and I need to subtract the radius of the planet from the orbital radius. I was just about to do that incorrectly. So the altitude is the orbital radius, 12,300 kilometers, minus the radius of the planet, 7,250 kilometers. Yes, now that makes sense. I get an orbital altitude of 5,050 kilometers above the surface of this planet, whose diameter, not radius, is 14,500 kilometers, and whose orbital radius, measured from the center of that planet, is 12,300 kilometers. So, briefly, this little section here shows the relationship between planetary or central body radius, orbital radius, and altitude.